Hello everyone, welcome back to my channel. Have you ever looked at something like this and thought, what in the world does that mean? Then, this video is for you. By the end of this video, you're going to look at that equation and think, oh, that's easy. Today we are breaking down linear equations with two variables, what they mean, where they show up in real life, and three powerful methods to solve them. We are going all in. So smash that like button, grab your notebook, and get ready. You have probably seen equations like this. That's a linear equation with one variable. Just solve for x and you get one answer. That is x equal to 9 over 3, x equal to 3. Done. But now imagine this. You are at the shop near your school. You have exactly 200 rupees to spend. You are there to purchase pencils and pens. Pencil cost 8 rupees and pen cost 20 rupees. Now, the question is, how many pens and how many pencils you are going to buy? Exactly. We are going to form an equation out of this. That is 8x plus 20y equal to 200. That, my friend, is a linear equation with two variables, x and y. The standard form of this equation is ax plus by equal to c, where a, b, c are real numbers and a, b are non-zero numbers. The word linear means the variables have a power of 1. No squares, no cubes, just plain x and y. Clean and simple. Now, here's where it gets interesting. With one variable, you get one answer. With two variables, you get not one, not two, but many solutions. Wait, what? Let's go back to our pencil and pen equation. 8x plus 20y equals to 200. Let's consider some values for pencil and pen. X is pencil and y is pen. When 5 is value of x and 8 is value of y, that is 5 into 8 is 40, 8 into 20 is 160, 200. When we consider x as 15 and y as 4, 8 into 15, 120, 20 into 4, 80. Again, true. When we consider 10 and 6, 8 into 10, 80, 20 into 6, 120. Again, true. When we consider 25 and 0, 8 into 25, 200. 20 into 0, 0. Let's consider last value, 0, 10. 8 into 0, 0. 20 into 10, 200. Now you can see that all these values for x and y is a solution. And if you were to plot all these solutions on graph, you get a perfectly straight line passing through point 25 on x-axis and point 10 on y-axis. That's why it's called linear equation. It makes a line. When you have two linear equations together called a system or pair of linear equations, and you need to find the one solution that satisfies both. We have got three methods of solving for them. Let's go. Method 1, graphical method. The first method is the most visual one. You literally draw the solution. To solve, we will consider some values for x and y. When x is 0, y will be 5. When x is 5, y will be 0. And when x is 3, y will be 2. For second equation, when x is 0, y will be negative 1. When x is 1, y will be 0. And when x is 3, y will be 2. Let's plot graph for this. Now we have to carefully plot all the single points on graph individually. For this plotting, we will start from the first equation and then we will move to second equation. In our first equation, the points are 0 and 5. Second point is 5 and 0. Third point is 3 and 2. After plotting this point, we will draw a straight line passing through all these 3 points. You will find that all these 3 points are collinear. Now, let's move to second equation. First point is 0, -1. Second is 1, 0. And third is 3, 2. Once we drew line, you will see that both the lines are intersecting at one single point. That is 3, 2. And that is our solution. This point 3, 2 satisfies both the equations. Let's check it. 3 plus 2 equal to 5. 3 minus 2 equal to 1. Perfect. The graphical method is great for seeing the answer. Method number 2, substitution method. Think of this method like a spy operation. You take one variable, express it in terms of the other, and then you sneak it into the second equation. Sneaky but brilliant. Let's see our problem. X plus y equal to 5, x minus y equal to 1. From the second equation, isolate one variable, x equal to y plus 1. Then substitute this into the first equation. It will become y plus 1 equal to 5. That is 2y plus 1 equal to 5. 2y equal to 5 minus 1. 2y equal to 4. Y equal to 2. Now, plug y equal to 2 back in first equation. So, it becomes x plus 2 equal to 5. X equal to 5 minus 2, that is 3. Now, we got a solution. Value of x is 3, value of y is 2. So, our solution set is 3, 2. Substitution is super powerful, especially when one variable is already easy to isolate. Method 3, elimination method. The elimination method is all about destroying one variable so you can freely solve for the other. Look at the coefficients. Both equations have x and y, but in the second equation, y is with a negative sign. Perfect. Add both the equations. X plus y equal to 5 plus x minus y equal to 1. Cancel out y. 2x equal to 6, x equal to 3. Now substitute x equal to 3 into either equation. X minus y equal to 1. 3 minus y equal to 1. 3 minus 1 equal to y. Therefore, y equal to 2. Our answer is x equal to 3 and y equal to 2. What if the coefficient don't match? No problem at all. Just multiply one or both equations to make them match. That's all for the elimination method. Linear equations with two variables are everywhere in real life. Grocery shopping, speed distance problems, business profit. Anytime you have two unknowns and two conditions, linear equations are your best friend. All right, let's do a quick recap. A linear equation in two variables look like ax plus by equal to c. It has many solutions forming a straight line on a graph. When you have a pair of equations, there are three methods to solve. First, graphical, second, substitution, and third, elimination. That's a wrap on today's linear equation with two variables. Don't forget to subscribe to my channel so you never miss a video. Until next time, study smart, live bold, and remember your brain is your greatest superpower. Use it wisely.